This is Desired State, close look at our PowerShell and DSC integrations with Chef. So I work at Chef, as is clear by the title. What we're going to talk about today is what do we know about Chef. We're going to have a look at our history of PowerShell and Windows support. And we can look at what problems we're still trying to solve at Chef to allow people to automate properly on the Windows platform using Chef and PowerShell. I'm going to aim to do that through the gift of demos and copy, paste, and typing, and so on. And then we'll have plenty of time for questions and feedback, kind of as we go. If you have anything you kind of just want to yell out, feel free to. I know it's kind of an intimate space. What do we know about Chef? So who here has used Chef? Okay, good sort of, what's that, 10 of you, okay, roughly. So that's a good number. For the rest of you, what do we think about Chef? What do we know about Chef? Anything? In the sort of a little bit, okay. So Chef is a configuration management system. I call it a policy management system, really. What we're interested in is maintaining the target state of a system from drift, and our tool set allows for detection and correction of sort of infrastructure artifacts. We have a client called Chef Client and a server, strange enough, Chef Server. The client talks to the server and retrieves down the configuration. So we're a pool-based model. We don't sort of push anything out. The server doesn't do any talking to anything else. Chef's written in Ruby, and benefit of Ruby obviously is Chef started on Linux. It's cross-platform. When Chef project started in 2008, 2009, Ruby was pretty much the dominant kind of language for people who wanted to do DSL development, so domain-specific languages. And Chef's architecture is basically the payload for configuration is a cookbook. There's obviously some Chef kitchen and recipes and all that kind of terminology to come, don't worry. But cookbooks are formulated based on recipes. And those recipes are simply files that contain lists of resources. And those resources can be resources that are in core Chef, or they can be resources that are you have written yourself as a custom resource. And you can bundle that resource either within your own cookbook, or, as we like our contributors to do, we want people to bundle resources into cookbooks that are then turned into libraries that are uploaded to our supermarket. And when they're uploaded to our supermarket, another food reference, those cookbooks are then available for use for other companies to use, and we get the benefit then of kind of reuse and the expertise of companies who've contributed those cookbooks into our supermarket, so you don't have to use them. You don't have to kind of code everything yourself. So our ecosystem is very much based on the contributions from our users. So we talked a little bit about resources, and I'll get on to hopefully quickly demos, and you'll sort of be a bit more visual because I'm not looking to stick to these slides for very long. We have attributes, and attributes in Chef are, we have a tool called OHI, and OHI is a profiler for a system. It profiles a system and returns the profiled information back to our Chef server. You can also use the profiled information inside your recipes, which makes them sort of quite useful if you're depending on a specific CPU type, or maybe you might need to be on a specific network for some configuration to be applied to your system. then that's what these automatic attributes allow for. And then we have custom attributes that you can use within your cookbooks that allow you to define sort of variables, if you like, for your cookbooks that can be overridden on an environment by environment basis. And that allows you to enact a correct pipeline and allow you to sort of productionize your application so that you're not just writing cookbooks for one specific environment. On the client, we have this thing called, we call it two-phase compilation because there's no compilation done on the server. The server doesn't know what resources need to be executed on the client. We just distribute the whole payload in the form of the cookbook to the client and let it do the work. And that work is in two phases. Because we have the Ruby language around our resources, there's a compilation phase where we determine what's sort of what resource the resource list is to be in the wider form, and then an execution phase where we go literally top to bottom through those resources that we've kind of compiled into a big list, and we go through them resource by resource. And each resource itself is responsible for picking up the current state of the system and determining what to do to get your system to the target state. And I already mentioned the ecosystem, but that's really very important to us, and it's something we want to preserve with our support of Windows and PowerShell going forwards. So a brief timeline. We'd have no support in Chef. If you wanted to create a scheduled task in Chef in 2003, scheduled task is an interesting example. We'll come on to why shortly. We had no PowerShell support in 2003, and if you wanted to create a scheduled task, we would shell out to schtasks.exe and provide all the parameters, and I'll show you the code for that shortly, but it's horrendous. And this is kind of one of the things over the years that has prevented people from contributing to our project. Quite frankly, we need much more clarity on the usage of, we need people with the expertise in using commandlets and the Windows platform itself to bring that expertise into Chef. And when in 2003 we weren't providing anything for that. In 2008 we added, when roughly PowerShell 3-ish, we added a PowerShell Out mixin, so you can call PowerShell directly from your custom resources within Chef, and that allows you to execute basic script. And I'll demo each one of these shortly. 2012, when PowerShell 4 came out, we added a DSC script capability, which basically takes the DSC that you would write normally before you send it off to the LCM, and you put that into our recipe, and then we will apply that to the local machine. That wasn't really very good. It wasn't easy to determine what the status of the outcome was after you applied the DSC. So when WMF5 came out, we built DSC Resource, which is a much more testable approach, where DSC Resource is a resource that has custom properties that are settable in a similar style to writing DSC for in PowerShell. Which kind of brings us to where we are, and we'll look at the future, and I want really your feedback about what we might do, and I'll be here and in the hallway after this. But we want our contributors to build amazing things for their environments, using their existing skills and knowledge. Frankly, the current way we execute PowerShell via via Chef is not the fastest. There's a history of kind of screen scraping and hacks to read standard out and then strip the white space characters off the beginning and end, and then use that as a variable that's an input into something else, which is, a traditional approach with most kind of scripting, if you're in Bash or so on. Those existing patterns, they deal with the script output, not objects. And of course, we love objects in PowerShell. So we're going to sort of close this down for a bit. And of course, the first thing I'm going to do is, this is our Chef. This is a Git repo pointing at Chef. And of course, the first thing everyone does in the morning when they get in is going to be git pull. But this is where I get to see what my team has changed since last night. Not very much, luckily. Okay. So this is the Chef code base, and we'll kind of come back into it. We've got a whole bunch of things going on in here. I've also got a repo full of demos, and I'll tweet out the link if you didn't sort of pick it up, or we'll go back to it. So in Chef, I mentioned the payload for developing in Chef is a cookbook. So this is a repo that contains cookbooks. Curiously, well, not curiously, the folder is called cookbooks. We've got a cookbook called demo. That was the most original thing I could come up with this week. Within demo, we've got files, so you can distribute files with your cookbook if you wish. We've got recipes, and those recipes are executed through our Chef client. And normally you would upload this cookbook after you've done some testing, and if you're interested in sort of the testing side of this, I've got a session on Friday. We're looking at a tool that we use at Chef for testing cookbooks. Actually, I say testing cookbooks, I actually call it development. It's a tool we use for developing cookbooks called Test Kitchen. We'll go through it all on Friday. The other things about, cookbooks contain recipes. That's probably the base level that you need to know at this point. So here's like a very simple recipe. So, how much can we see? That might be a bit better. So this recipe has two resources in. The first one is called cookbook file. And what cookbook file does is allow you to take a file that you've distributed with your cookbook and put it in a location on the machine. And I put it in this kind of notation here is like an interpolation of our file cache path, basically, so that this is used intensively by Chef. And if that file exists there in the future, you won't need to kind of put it there again. I've just pulled down, in this case, the X certificate resources from the PS gallery, actually pulled that off GitHub. And then we've got, this is our initial idea of integration with DSC, and we called it DSC script. And DSC script has one main property called code. This is going to be pretty simple. And inside code, EOH is end of here doc, and so anything between this line and the end of here doc down here is just treated as a string. And so literally we've just pasted in here a DSC resource. So if I actually go to my machine, and we can run Chef clients in this thing called local mode, which is -Z or minus local mode. and then you specify the recipe. And the recipes are namespaced, so from the root of that repo, I'm calling demo1. Now what should happen here is starts up my Chef client. It's now running through those two resources I've got. So cookbook file doesn't. If there was a file there already, it would do a diff and then show you the diff, but it's binary, so it won't. And then behind the scenes, we converged this DSC resource, which was just an archive. I just ran an archive on X certificate to extract the contents of that zip file into my modules path. And I don't know if you saw in the recipe, the modules path I picked up using an environment variable for program files, Windows PowerShell modules. That's all it is, pretty simple. And the way we actually do this in Chef, I go to the Chef code base and have a look for DSC scripts. So resources in our core Chef product have kind of two components that in the core code base. We actually have the definition of the resource itself, which goes in a fold called libchef resource, and then we have a provider for that resource that provides all the sort of functions and things we need to do to actually get the thing to the right state. If we have a look at the code for that, we can see it's pretty. So this is the resource, and you'll see we have a method called code, and we do some checking to see if someone specified a command, because that's another property that you could specify on this DSC script resource. And then we basically set this variable up called code, and that's all that we do on the resource side, is just sort of setting properties. On the provider side, we have provides DSC scripts. That's our way of Chef telling us what's a valid resource name. And we have some methods in here that detect whether you've got PowerShell on your system. And so requirements is like a core object in Chef, and you can run assertions against core Chef just to see whether we support DSC. Supports DSC is a method that checks the PowerShell version. You may remember I talked about this tool called OHI earlier. We are checking an attribute that's returned to us from OHI to see whether we've got the right version of PowerShell installed. And then we've got a library here called chefutil DSC Local Configuration Manager. And it sounds kind of like we're interacting with LCM somehow. But actually, it's like, before we get to this point, what we've done is basically write out that script block onto disk in a PS1 file. And all we're really doing is executing that and then triggering the LCM. That's what that local configuration manager object is responsible for. So that was our kind of first iteration of it, and it worked okay. But it's not very testable because I can't test what's inside that code variable. So we, if I run my clean up just to make sure I'm in the right state. We go on to the sort of second piece of this. So this is like the second iteration, same cookbook file, and now we have a resource called DSC resource. And DSC resource is a resource that we added to Chef. It has properties where the value of the property matches the the name of the DSC resource you want to execute, and the value of any custom properties are passed in. So this is the same as demo 1, but using our new approach. And the benefit of this predominantly is that we have a whole bunch of testing tools that, well, first of all, we rewrote this a little bit to be WMF5 compatible, and to do that we had to, we went through this process of, at one point we couldn't disable the LCM's refresh interval. Obviously you don't want Chef and DSC fighting with the configuration you've put into the system. So you want one or the other to win. We want Chef to win. So whenever you execute DSC resource, we set the refresh status to disabled and then manually push our config. And if I run that demo 2, then you can see we got a bit more kind of verbose output, because kind of people told us, well, maybe we should provide some output. That's a major difference between the V1 and the V2. And you can see it's basically exactly the same process that you would get as if you were distributing this configuration locally and then applying it. And it tells you how long it took to complete and so on. And if I run this again, you can see it says 2 out of 2 resources updated. If I rerun the Chef client, then what we want to see in a successful run is that we should have 0 resources updated. And that's basically because, and you see in the output here, each of those resources that was executed, file and DSC resource, it says they're both up to date, so they're in the correct state. So this is quite a convenient mechanism then for distributing DSC around the system. So I'll move on from DSC a little bit. And talk about something else that's in Chef. So this is like the same as demo 2. We've added this log resource, and all the log resource does is add a log message into Chef's log. At the end of a Chef run, by the way, every message that's received gets sent back up to the Chef server, and then you can sort of query it later on and do interesting things like use the attributes that were returned to assign a new run list to the server if it's missing a patch. If I run this demo 3, then you'll see here are our first 2 resources that are running, and our third resource was skipped due to action nothing. And so every resource in Chef has an action, or one or more actions. The default action on log is an action called write. But the thing I want to show you in demo 3, if I run this, if I run my cleanup again, just to get back to a clear state, is that resources in Chef can notify each other once they've been executed. And so this is a DSC resource that notifies the write action on the log message immediately after it's been updated. So in the last run, DSC resource didn't update any resource, so no log message was produced. If I run this again, I've got the Chef client, copies the file. Well, it doesn't copy the file because it's already in a cache. DSC resource runs, and now we see a message in the log, I have finished. And that was the sort of notification mechanism from one resource to another. So in DSC, we don't support depends on, for example, to like organize DSC resources, because we expect people who are writing recipes in Chef to do DSC actually put the DSC within Chef's framework rather than trying to import a big block of DSC. And so there's notifies on a resource. The other way I could have written that is have the log, the log resource subscribe to a change in the state of DSC resource. And so I can subscribe a log to one or more resources in there, which is it's actually quite powerful when you think about it. That log could have been a reboot, for example, and that reboot might be the timer that's used could have been at the end of the recipe, or it could have been immediate. So you get some choices and some control about when you actually want to reboot the system in the middle of your workflow. So I talked about we added PowerShell Out support, which is just our kind of way of letting people execute PowerShell on the system. And so to support that, we have a resource called PowerShell Script, and PowerShell Script's used in a lot of cookbooks that people have written on Windows to work around different features, things they can't do with built-in resources we have in Chef. We have a lot of built-in resources, and we're adding more every release. Most of them have been contributed by the community, and we pull them into our core Chef on a very regular cadence. But obviously people want to do some sort of interesting custom stuff with PowerShell. And so we have this PowerShell script resource. This is what demo 4. And all PowerShell script does is very rudimentary. It will take the script block that was in code, write it into this chef script date and a temp file name .ps1, and then execute it inside PowerShell minus no logo, non-interactive, no profile, specified execution policy. You can override all of those attributes using the properties of the resource, but it doesn't give you a lot to work with. In this case, what did it do? I think it probably it should have created a PS version file on my desktop. But that over time, we have, as our Windows support has progressed through our product set in Chef, we've needed to do more with PowerShell, and just shelling out to PowerShell hasn't been particularly sort of great for us. Especially, we've got a compliance product called Inspect, and what Inspect does is runs remotely against a machine and tests the state of various resources on the system. We do a lot of that through PowerShell, and so there are a lot of calls to this PowerShell out method, which triggers a new process of PowerShell.exe, and you do that 200 times in one script. It is time consuming, and it's been a feedback that we've had from customers that maybe that could be improved. So we actually took a look at it. So this is behind the scenes of PowerShell script. There's this method called PowerShell Out. I've just picked something very simple that returns quickly and gives me some sort of object. So this is what people are doing at the moment inside their recipes to build a custom resource that uses PowerShell. They're basically calling PowerShell Out, and then we've got this method standard out, which you can can call on the object that gets returned. And just puts in Ruby is just kind of spit out to the console equivalent. And in Ruby, we have this kind of interesting language, 50.times do, which is pretty self-explanatory, I think. And if I run that, you can sort of see the explicitly why things are slow, because we're just kind of calling PowerShell. This is like okay, it's not that slow, but it's if you've got 10,000 machines and you're calling 200 different profiles on each one, it takes some time. So for Chef 14, now Chef 14 we just released the Chef client last week, and we're in a bit of a limbo period, I say, because we've released the Chef client, but we haven't released the development kits for the client yet. So that will be coming kind of next week, which makes kind of setting up for this demo quite interesting. But to improve the PowerShell support, we decided, we looked at kind of a few different options. So one of the options another of our projects has adopted is to start up a server with PowerShell.exe running at the start, and then kind of pumping in commands into PowerShell.exe over a named pipe, and then retrieving the output. And that works for certain types of projects, but where we've got a single execution of the Chef client to run with, that didn't work for us. So we looked at different interfaces into PowerShell. But you can see here we've got, this is just the standard out that was returned from that command, get culture pipe select display name. And one of the things we want to do is work with objects. We don't want to work with standard out. I hate working with standard out and trimming off new lines and all this kind of stuff. And people who work with Chef and Ruby and Linux environment are just used to doing this thing, and they use sed and awk and all these fancy tools that I don't get along with. So we built a new PowerShell Out. And if I go into Chef Shell, so Chef Shell is a tool that is used actually for debugging recipes. Very kind of little known tool, but as actually you can literally go into Chef Shell, go into recipe mode, and then type your resource in, and then do a chef run directly. This is just as if I'd gone into Chef client and provided some Ruby code. So now we have, before we have PowerShell Out. If I do PS version table, and we get this kind of object back, which is, interestingly, it inherits all the way down from, it's inherited from our execute shell out object, ultimately, because ultimately it's running this command, PowerShell.exe, blah, 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 and then returning us some standard out. This is horrendous to parse. So we wrote this thing called PowerShell exec. And PowerShell exec returns us a result that is the equivalent of kind of a marshaled operation via a conversion to JSON. So imagine if you've got you've got PS version table here. This is the same as if you type PS version table pipe convert to JSON and then have it returned across the wire. And the bit in the middle is these kind of 30 lines of C#, which we have this thing called just an execution object. It's just a very simple kind of contract that returns us, is an object that returns us the execution result and any errors that came back. And what we're doing behind the scenes is exposing this through COM. So I thought I was done with kind of COM in the 90s somewhere, but clearly not. And Ruby has very strong kind of COM support, so we decided to go this way. It's a very simple thing to do to use the PowerShell engine, add the script to the PowerShell engine, convert to JSON. And we're going to play with this a bit more. This is kind of the first iteration of it. If we have a result, we'll put it in the results. Otherwise, return a symmetric JSON so we don't break things all the time. If we get errors in the error stream, we just kind of create an array of those errors and return those as well. Then we serialize that whole execution object and return it back to Ruby. And this is a .NET. We just build it in .NET. It sits in AppVeyor. Any changes to it, AppVeyor just rebuilds it. And then we include, to distribute it, we distribute the registry entries that do the COM registration in the Chef client installer. But now, of course, we've got, we can do this kind of, execution equals PowerShell PS version table. And then type execution dot result. But now we can work with execution dot result PS version and get and actually work with it as a Ruby hash. And the same works for, if I've got like a hash table, like something simple like environments hash table with the names of servers for each environment. All I need to do is the same sort of thing. Execution equals PowerShell exec. And then we can check for whether there are any errors in that execution. Those errors will be an array if there are any. And then we can set like execution.result dev will return us the server name for dev. And we're basically marshalling the information that goes back and forth between PowerShell and Ruby. And so that's quite a big kind of win for us. There's no PowerShell.exe process involved. If I come out of this and go to the next demo, which was 7, because that last one didn't have anything in it. Demo 7 is exactly the same as demo 5, but through the new way. And so there's no extra PowerShell.exe processes involved at all in that. And it's about 7 times faster we've tested it on kind of 100 cookbooks across in our test suite, and it kind of averages out about 7 times faster on all the PowerShell code. And we get objects returned rather than having to deal with string manipulation. Yes?
There is no stickiness of functional variables use everything after PowerShell exec?
Correct. And that matches up with each resource within Chef. So resources within Chef are not designed to communicate with each other anyway. But within Ruby, you can assign a variable to the outcome of PowerShell exec, and then use the information within it. Throughout, as long as it's within the resource block, it will still be in the scope that's required. So that was the demo 7. So there's, everything you probably saw visibly, it's much faster on its own. And so I just kind of wanted to show you what a custom resource would look like if you were choosing to build your own resources and distribute them with your cookbook. So we've got this, I wrote this resource called PowerShell Custom. It's basically a short version now of PowerShell script because it takes a name, and we have this thing called name property. So in a resource, this thing after the name of the resource is the value for the name of the resource, and this resource takes one property called code, which within our custom resource, all we have to do is declare that we have a property called name, and it's a name property, a property called code, and it's a string. Within a custom resource, we say, right, here are my actions. So the first action in a custom resource is always the default action to take, so you don't have to specify it. But if you did want to, you could come in to the resource and say action execute. That's the longer way of saying that. But if you wanted the action to be something else, like run, that's also possible. And you could build another action called run, do, and then do the things in that run action. And the cool thing about the custom resources in Chef is that they can include any core resources that we have as well. So you can use this to wrap up blocks of execution for specific kind of applications that you have. If your application or your deployment process needs, I need to copy this module from this place to this place, and I need to unzip it, and then I need to execute this command to activate it on the system, you can wrap up all of those resources into a single action that sits inside a custom resource. So this is what it looks like. It's going to be pretty boring. We can see in here, all I did was spit out the output from the PS version table, but it runs a lot faster. And what we actually want, if I sort of flick back to slides, unless I stopped it. Stop it. So what we actually want is for people to contribute. Yeah. So these are the problems we're trying to solve. We wanted people to contribute using their existing skills and knowledge of using PowerShell and bringing that into Chef. We've hopefully solved the script executions not being fast. We've solved the screen scraping and the hacks that people did to execute one script block and then read the standard out and trim the output and then use that as an input to something else. And so we're hoping that this will allow contributors and ourselves, so we want to use this internally now to build out the rest of our support for PowerShell and other things. Just to summarize kind of the things we went through, DSC script example, the resource, the notifies and the subscribes and the resources, PowerShell script the old way, and the benchmark, and then PowerShell exec, which is the new way of doing things, benchmark for PowerShell exec, and a custom resource example. What does the future look like? Well, who here has had any dealings with Honolulu or Windows Admin Center? Okay, a handful of you. So the neat thing, I think, about Windows Admin Center is it gives us a set of primitives to work with. So Chef has primitives in the form of the core resources. So file resource, directory resource, they're kind of Chef's primitives, if you like. Whereas Windows Admin Center is being very explicit about this is how you manage a Windows system, and here are the objects that you can set properties on. And if you kind of combine where I think we need to be with that work, which on the face of it feels like a small piece of work, I'm hoping it's going to open up our access into kind of the new world of Windows administration via the Admin Center. We should build some core resources into Chef that allow you to set any object on the Admin Center to the target state. It should be able to detect the state. Sounds pretty simple. Now I've shown you all the raw materials that we've built within Chef to do that. PowerShell core. We haven't got an explicit target for integrating PowerShell core. The things people have approached us for at the moment with PowerShell core is, we need to install PowerShell core on these 7 different platforms of Linux, and then test our scripts there. And you know what? Chef's got a pretty good story about testing across multiple platforms, and I want to talk about that more on Friday. But we're not planning at the moment to switch away from the system Windows PowerShell. But we do have some work to do within Chef to move away from WMI. I was reviewing the code base a little while ago, and we're still using some WMI bits that we need to swap over to SIM and so on. And then another thing that's probably exciting to us in the longer term, mainly because everything I've shown you today is open source. It's all on GitHub. You can download the code yourself. The whole of Chef's open source. Everything I've shown today. And open sourcing an LCM is kind of particular interest to us, because that means we might have a different way in the future of integrating directly with an LCM rather than going through an intermediate step. And that's kind of the story so far, and I think in the future I'll be able to come back and state which kind of path we've gone down, but also we need your feedback about what you would actually use out there. And I think there's about 10 minutes left for feedback and questions. Yes? PowerShell exec is not in Chef 13, no. It's only going to be in Chef 14. And so Chef 12 has just gone end of life, because we have a yearly release cadence on Chef. Yeah. Mm-hmm. Yeah. Mm-hmm. Right. Yeah. Yeah. There is definitely an approach for migrating from Chef 12 to 13 and 14, and a lot of it, we've tried to codify a lot of the changes that have been made in Chef 13 and 14 into, there's a tool that comes with the Chef development kit called Food Critic. And Food Critic is a tool you run against your cookbooks. It tells you which of the methods that you're using out of Chef are no longer available. It also identifies other problems that your cookbook might exhibit if you were to upload it. And so, yeah, we appreciate there is a a testing cycle that you need to go through, and in your case it sounds pretty large because the number of cookbooks involved. We're not planning to backport to 13 at this point. Yes, I mean, so we ship the assembly, and we ship the registry entries in the installer. The registry entries are also in the source, so it'd be quite easy to just ship the registry entries and the DLL. Yes? Yes, correct. That's correct.
Okay. Then which benefit do I get? I mean, from looking, so like how people do DSC as a right language script which generates more and then apply one configuration.
Yeah.
And in this case, I don't know, I need to write like 22 resources in this format. And so for me, it's like the first idea was, okay, if I want to use it, I will just write some script which actually converts all my current DSC in this format. Yes, it means like a format, but I don't see like why should I do it?
Yeah. So you can use DSC script if you want to incorporate a kind of a larger. Oh, sorry. People at the back. So the summary of the question was, if I've got kind of 5 resources in DSC, what benefit do I get by separating them out and kind of putting them in Chef? And what the focus for us is the ecosystem and the contribution to our ecosystem, and the compatibility between resources and the existing way of doing things in Chef. So people who use Chef are kind of more comfortable with the notifies and subscribes between resources. I agree with you. I think there's a timing point. Do you have? Sorry, you could. Yeah. So. So, if I go DSC resource in Visual Studio Code, this was an extension I wrote a couple of years ago. No, not yet. Right.
Because I can have medicines and I can see which properties are there, and then it was updated.
Yeah.
Just because it's updated, it has additional properties, and can also see it.
Okay, so.
It would be actually really helpful.
Yeah. So the question was, can we have IntelliSense on the resource values within a Chef's DSC resource? And I think it is technically possible. We are working on a language server implementation for the Chef language, but it would only cover the first level of the resources and the resource properties. And to be honest, we're working hard to try and get that IntelliSense working for cross-cookbook dependencies. So that people can literally, if they've got custom resources in one cookbook, they'll be able to start typing the name of that resource and it will come up with the list of properties. And one of the things we've been doing in Chef 14, if I look in our code base, if I look at now any of our resources in our code base, you may have seen that we started adding descriptions to them so that they've got kind of information there. Trying to think of another one. But our resources are now marked up so that we can take an extract of them and use it in a language server within the Chef DK. That's one thing that we're working on.
flexibility to have a configuration file and then view my resources when you need configuration.
Yep. So environments with Chef are
Multiple sources in one file.
yes. So each recipe that you see here gets added to this thing called a run list. The run list is stored against a node object, which is a representation of the server that's actually, and that's stored on the Chef server. And so you can talk to the Chef server and say, I want all the servers in this group to run this run list. And you can use things, you can use a Chef construct called a role to accomplish that. Or you can directly assign the run lists directly to specific servers. So yeah, we've got environment constructs, and that allows for the environmental overrides that are needed. But ultimately, this cookbook gets uploaded to the server, and each client gets that whole cookbook. And the logic then that's required is all executed on the client. So there's no kind of server-side interaction in that process at all. Okay. Any other questions? Yeah.
I have a little bit to ask. Now it's lunch, and would it be possible to use PowerShell because
Okay, so now is lunchtime. We're going to, did you say eat outside the room? Okay, so if you could kindly leave. Thank you very much. I'll be outside.